Our next panel, Solutions in Healthcare, will be led by Jason Tester. Jason is a futurist and research director at the Institute for the Future. So I asked him earlier for the lottery tickets for next week. He didn't quite have a number, but Jason, a native son of Detroit, does see a brighter future for the Midwest and for the auto industry and the revival of that city. That topic, while not the center of today's discussion, perhaps might give you some idea of his views on the world. So Jason, if you would please join me in welcoming Jason Tester and the panel.
Thank you. So I think we have in our pre-discussions, we've been trying to figure out what's exactly the common theme for our panel. I think we're a bit of a motley crew, and especially my panelists. This may be the panel of war stories, kind of early war stories from these pioneering days of getting towards ambient intelligence. And I think we look forward to all of you helping us figure out what are the emergent themes across these domains and across these applications. As Matthew mentioned, I'm with a think tank in the area called the Institute for the Future. And I wanted a lot of the themes of today overlap with the work we're doing. And I wanted to share a bit, pull back the curtain on how we do technology forecasting as it relates to the future of ambient intelligence. So as I mentioned, IFTF we're a nonprofit futures research group here in the Valley in Palo Alto. We're 45 years old this year. One of our founders actually helped to invent packet switching. So in a way, we've been well situated to look at what is the future of a networked world. We do a lot of work on technology, on health, on learning, governance, and the future of kind of global politics as well. I want to talk specifically about our tech forecasting program, which is a couple decades old. When we do tech forecasting, we really try to look at three areas and the intersections between these. And these three areas are context, creators, context, and computation. Now, creators, this is, a lot of the engine of creativity is in a room like this, is with industry, is with R&D labs. But we also try to look at what are the lesser known stories, the repurposings, almost the shadow side of innovation with a lot of technology. Often, it is on the streets. More than labs, at least some of the more novel uses. So we're looking a lot at the DIY community, at makers, at hackers. We're looking at open hardware and hardware startups. That the phrase hardware startup is a phrase that's coming up a lot nowadays. It talks about a new kind of innovation pattern for how we're getting to a world of ambient intelligence. I'm going to show an example that emerged from crowdfunding. We're looking a lot at crowdfunding platforms as a kind of an emerging alternate path to innovation. And what does it mean when the process of getting money and getting resources actually also creates a community, a built-in community at the exact same time as you get that funding. And then finally, we try to look a lot at what innovation is coming from the informal economy. Or the shadow economy, both in ways that are, range from off the books to off the law almost. What innovation is happening there? So the third area I mentioned, the second is context. So how is technology being used? What needs is it solving? And here we look at, what are the leading edge needs and uses in the home, in the workplace, in cities, and what are those regional differences around the world? And the last one is computation. I mean, computation is really the driver of a lot of this. And I'm going to talk about three eras that we're describing for the future. The era of abundant data, the era of the Internet of Things, and then finally the age of network matter. For the first story of creators, I just want to show a couple examples of kind of these grassroots DIY-led innovations in ambient intelligence that I think are really worth watching how people are using these technologies in new ways. Does anyone have a Twine device, a Twine sensor? It's a pretty simple sensor. It can detect temperature, vibration, and orientation. So all in that little green box. And it can connect to the cloud. It can send you an SMS. It can send you an email. It has an API, so you can just monitor the data stream. Twine was crowdfunded on Kickstarter. And one of the early kind of breakthrough hardware successes on Kickstarter. So much simpler than a lot of the applications for ambient intelligence that we're talking about today. But I think still really interesting to see what are these pioneers doing. We looked at some of these early DIY examples of Twine, and some of them are what you might expect. If the Twine detects motion, turn on my web-enabled webcam, right? Or Twine is getting some uptake in kind of caregiving communities. I mean, the overlap between ambient intelligence and caregiving, I think we'll discuss today, is so ripe for innovation. Someone created Twine to, it's almost like a help bell for a sick relative. So when they flip the Twine, it sends a tweet to their network saying, I could use some help right now. And the last one, the one that we love, is that one father, when the closet that contained Christmas gifts was opened, it would send him an SMS right away to say that, the secret had been breached. Take alternate action. So just really interesting to see what are these early applications, particularly around open hardware, once this is in the tools of people who have some ability to start creating. This is a hack that I love. It's a hack that stitches together the Fitbit personal activity tracker, a Belkin Wemo, which is a Wi-Fi enabled kind of power outlet, so turn off and on, something that can just be plugged in, and then finally his refrigerator. So this was someone who bought a Fitbit, and the gamification aspect of Fitbit, so it encourages you to walk more, to move more. The gamification aspect wore out quickly for him, and then he put the device away. So he said, okay, I need my own motivation here. So what he did was he basically hacked this system together to his fridge, so that if he does not walk enough and move enough as sensed by his Fitbit, it kills the power to his fridge. That will cause his food to spoil. And I think this really points to, not just a hack, not just kind of the ways that the street is telling us people want to use these devices, but particularly, as ambient intelligence enables us a new world of personal improvement, a world of behavior change, we need to understand that a lot of the motivations for that will be different for almost all of us. For other people, the badges may work. Other people, it may be social proof. In this case, it was something as dire as food spoiling. And so that understanding almost our individual persuasive profiles will be important in this future. The last one on creators I want to talk about is, this is called an air quality egg. It's another DIY kind of open hardware. I think it's based on Arduino. And it's an air quality sensor. It's a cheap, semi-mass produced air quality sensor. And they're trying to get these as many hands around the world, really to fill in gaps in air quality sensing infrastructure. Many major cities around the world have only a couple, a dozen or fewer official points of air quality sensing. And so a device like this, especially, this is a real-time map of air, they're called air quality eggs that are online around the world. This can really invert, this can really invert the balance of almost control of power of authority as more people have these devices for sensing and for ambient intelligence. And I think this points to a world where the crowd's ambient intelligence may be different than the official. And that back and forth dialogue or conflict will be really interesting looking forward. Context. Tom already mentioned a lot of the work that Intel is doing in cities. And so I'll go quickly over that. But cities is the context that we're starting to look at a lot more these days. 2008 was a big year for cities. It was the year that the human species, the human population, crossed the threshold into being more urban than rural for the first time. And that trend line is only going up. 2008 was also the year that we became untethered as a mobile species. Where mobile connections outnumbered fixed line connections for the first time. And so we're looking at cities cities are where mass migrations, and an untethered world, and ambient intelligence and sensed objects will really come into play for the first time. We're using the phrase urban crucibles, that cities will be urban crucibles of innovation for, and very much ambient intelligence information. And cities are where problem havers meet problem solvers, meet legacy assets that with the addition of this ambient intelligence can be optimized and reconfigured to get more value out of these assets. And then finally, emerging tech. Now there's one early signal that I think brings a lot of this together that I want to share. Has anyone heard of the pulse point application? It's actually, it emerged here in the Bay Area. The San Ramon Fire Department, they were having shortages in traditional firefighters and traditional EMS personnel. So they created this application that would let CPR-trained citizens report their location to the emergency services, so that when a 911 call came in, if a citizen was within half a mile, a couple blocks, they would get the ping to respond at the same time as the fire department or EMS. And the last time that we had checked in with this group, no citizen had failed to respond if they were close enough when a ping came in. So this is having a really high success rate. And I think ambient intelligence is these are not just technical applications. This can really change the definition of citizenship and governance going forward in the future. And the last one is computation. In our tech work, I'll go quickly through this. In our tech work, we're starting to look at 3 eras. The era that we're in now, abundant data, big data. We're dealing with lots of information from lots of sources. The next era is the Internet of Things, and a lot of the conversation about what's next kind of ends at the Internet of Things. And so we challenged ourselves this year to say, okay, what's past that? And from pulling together a lot of different early work in 4D printing and synthetic biology and programmable matter, we think there is something kind of past that, almost just around the corner, that we're calling the age of networked matter. And as in an era when everything is connected, everything is reporting information about itself, has the ability to talk to other devices in this network, how this networking happens, what we're hearing will be very important. And so one analogy I want to use is that we're moving from a world of spaghetti connections, where everything has the autonomy and almost the equality to say, I want to talk to this device, I want to talk to this device. And in a way, if we scale from here, this is the world that we're building. Our investigation in this future is suggesting that we need to move from a network topology to almost a network neurology, looking at how the brain functions. And some of the characteristics here are really functioning, sense-making that can happen across scales, not just at one central point. That this network neurology is not a tripwire system, a simple, think back to the Twine, if this happens, do something. So that intuition can actually happen, that all the nodes on the network have their own form of intuition. And then finally, we need to move back into hierarchies so that information can be prioritized and kind of the locus of control is not just at one central point. And we're going back to the phrase, the sorcerer's apprentice. It's a very old poem from 1798. We've had art and literature and stories about the way that the world under our control could go wrong long before we had the technology. And so how do we become more like the sorcerer and less like the apprentice as we go forward? So those are the 3 pillars of how we're looking at this future. And I'm really excited to bring our panel up. I think we're actually going to touch on a lot of these areas. So our first panelist is Mark Zadiblik. He's the co-founder and CTO. I hope I got that right. I tried to practice. All right, thank you. Co-founder and CTO of Proteus Digital Health. And we're going to be hearing about the work of Proteus. Prior to Proteus, Mark was the CTO for the optical switch group at K2 Optronics. And as part of his PhD work at Stanford, Mark's work enabled atomic force microscopy. I also practice this word, microscopy. So Mark, we're looking forward to hearing from your work.
Thank you, Jason.
Thank you.
So I'm Mark Zdeblik from Proteus Digital Health.
Thank you.
There you go. It's all right. Don't worry. And Proteus is about 10 years old, about 100 people. We have offices, our headquarters in Redwood City. We have commercial offices in London and Hong Kong. We have manufacturing in Hayward. We have partnerships with Novartis Pharmaceuticals, Otsuka Pharmaceuticals, and recently we announced a partnership with Oracle for clinical trials. What I'm going to talk about is how digital technologies are going to bring better care for more people at lower cost. And you might think that's almost impossible, but that actually is the definition of what you have to do if you're in the medical community right now. You have to do all three of those things in order to be successful. Everyone talks about the high cost of healthcare in the United States, but that's really the tip of the iceberg. They're forgetting that there's 2 billion people on this planet who have no healthcare at all. Well, what you're competing with is nothing. It's a very different paradigm shift. And I'm going to talk by analogy initially, and then more specifically as to how digital technologies will bring all three of those things. And the analogy I'm going to use is communications. 200 years ago, if you wanted to have a dialogue, if Jason and I wanted to have a dialogue, we'd either talk to each other directly here, or if he was in California and I was in Chicago, we'd send a letter. And letters were so important that they show up in the United States Constitution, forming the U.S. Postal Service. Everything went to a central organization which took care of the handling of that mail, and then it was distributed. Then came the telegraph. We had an alternative. And then, of course, the telephone, and now the internet. The spread, the diversification, the democratization of communication, the going from a central location to a distributed network of nodes has now allowed, internet's 175 trillion pieces of email, over 4 billion users at a cost of 1,000 emails for 10 cents versus 40 cents for a snail mail through the Postal Service. It's completely changed it. You can't do Facebook with the Postal Service. There's things that you can't do with the Postal Service that are enabled by this revolution in communications. All right, so how is healthcare going to be like that? All right, healthcare is going to be like that. When you think about today, if you get sick, you go to the doctor's office and you talk to the doctor and they do something for you, and then you go home. And it's the Postal Service. The clinic is the Postal Service, intuitively. If you get out of that mode where you've got patients treating each other or helping each other improve their care, now you're beginning to see how digital technologies can eventually reduce costs. And it's even easier to see how this works if you go to a place like Africa where there is no health care, where instead of going to the doctor's office, they're going to go to their cell phone or go to the person in their community who has a cell phone and interact with technology that gives them a different type of care, completely different type of care, one that's not imaginable, because one hospital in Chicago is worth the entire healthcare system of a country in Africa. So this digital technology is now all over the world. Mobile technology is everywhere. And also the diseases of the Western world are now beginning to propagate everywhere. Affluenza, where we have more food than we need, causes increasing problems of, say, diabetes around the world, heart failure, other diseases. And some of these diseases are ones where individuals can help each other do things. Now, you may wonder, what's Proteus Digital Health all about? I'll give you a brief description of what we do. We put silicon chips inside of medicines, and so when you swallow those medicines, they communicate to a patch that you wear on your body or some other detector in the future. And that patch then communicates to a cell phone or a tablet or a laptop, goes to the cloud, goes into a database, and comes back to Earth. The system looks a little bit like this, where you've got a patient eating the tablets. They have the chips inside, they have the patch. That produces a data stream. The patch has an accelerometer, temperature sensor. It also has the ability to sense your heart rate. And from that, it can communicate, send information to the cloud that we know how much sleep a person's getting. We can figure out how much activity they're getting. We can make some metrics for that particular person. And here's a typical view. You might give this to a patient. This is actual patient data. The first patient on top is what we'd call a metronome. They take their meds every single day, 7 days in a row. They're at the exact same time. They probably don't need our technology. The one on the bottom is a more typical patient. They take them 5 days a week. They go on vacation on the weekends. And during the week, not exactly the same time. You may wonder, this is data. Now, how would you actually use this in a community? How does this go back to that earlier thesis of say the two of us, or better yet, say my two sisters-in-law who both had breast cancer. The first thing they did after getting breast cancer, well, they got treated. They had their surgeries, they had the radiation, and then they were given a 5-year prescription for a medicine. And if they miss 1 out of 5 doses of that medicine, their 5-year survival goes down by 5%. So one way they could help each other out is by helping each other take their medicine, but they don't have any tools to allow them to do that. But the one thing they both did after being treated was to go to a fundraiser. And they went to some fundraiser and they walked 30 miles and they raised money for the National Breast Cancer Foundation. Now, what if in the future we give them our technology at that fundraiser and they wear a patch and they're put and gathered into a random team of 12 people. They say, okay, that team that's sat at that table is going to be a team for the next 3 months. And those of you who take the most medicines as a team, have the best adherence to your prescription, you'll get a prize. You'll get some, award from a politician or a sports star or somebody. I used to say Lance Armstrong, and now I get mixed results on that. But somebody will give you an award for, helping each other out. So
at least he's good at taking his medicine.
Well, good point. Maybe I'll keep using Lance Armstrong. Anyway, if you read his book about what he did and still did what he did, I don't care how he did it, frankly. Most people would be, 95% of people with his condition would have died. So cut him a little bit of slack. In any event, you're now thinking about individuals at a table, randomly selected who have something in common, helping each other out and having a better long-term survival and getting better utility out of the medicine they've been prescribed. The medicine's there. It's how it's used that can optimize its results. It's a very simple example. Some of the other data we get are things like walking, whether someone's walking okay or not. And for, say, Parkinson's, where your gait gradually declines, this can become a metric that we can actually use to determine the efficacy of a drug for that particular patient. And we'll be gathering data about efficacy with specific drug taking, and then having in our data about, say, the genomic information of that patient. So multiple axes, genomic data, actual medication adherence data of what the molecule is, when it was it taken properly, and then performance data. Did this medicine in this particular patient with this particular genome have the result that you're looking for? So it's a very three-dimensional, very sophisticated, very valuable set of data that we'll be generating. And the lower one, we're looking at psychiatric patients compared to a normal patient. Most of us sleep at the same point in time every day unless we're traveling. It's typically you go to bed, sometime between, 10 or midnight, and you wake up, depending on your habits, sometime between 5 or 8. And it doesn't really matter, but most of us do the same thing every day. People who have neuropsychiatric issues look more like the one on the right. Those are days of the week going up and time along the horizontal axis. And what you see is sometimes they're in bed the entire day. Other days, they don't sleep at all. And it's totally scattered. So that can also become a metric for people who have neuropsychiatric disease. And looking at that patient population, the number one conversation at the dinner table is, are you taking your medicines? And they get tired of this, because it's when it's a question that happens every day, whether you behave properly or not, it's called a nag. If it's a question that's asked only when you didn't take your medicine, it's called a nudge. And only data allows you to deliver a nudge without being a nag. This is how the technology works. We have silicon chips, which I'm proud to say are made by the wafers, the CMOS wafers, come out of Fujitsu Semiconductor FSA out of in Japan. Soon moving their foundry from one to another, but we've been working with them for a few years to be the supplier of those chips. They go to Hayward, where we put magnesium on the bottom side, we put copper chloride on the top side. When those go inside the body becomes the electrolyte of the battery, and the chip modulates the battery current. And the modulated battery current shows up as an AC voltage throughout your body. And a detector ward on the body, on your person, actually detects that AC voltage and allows you to know that you read a certain number that comes out of there. And that number represents the medicine, the place of manufacture, the amount of how many milligrams of medicine it is, et cetera. And it's completely contained inside the body. It can't be read by an external RFID reader or anything like that. It has to be physically on your body. So it's unique to the patient. You know that person took that medicine. There's no ambiguity about it. And you know exactly the point in time. And that's Proteus.
Thank you.
Well, I'm going to stand up to talk because if I don't walk around enough, my refrigerator's going to turn off. Let's see if we can come in.
Brad, since you're up, would you do a quick...
You don't introduce yourself. You've got to do the intro.
I'm happy to do the intro. So Brad is the Network and Computing Chair at Singularity University. And he really is an internet pioneer, having created some seminal software and technologies that a lot of that are still influencing what we use today. He's an advisor to the autonomous transportation team at Google and blogs a lot about the future of autonomous transportation. And I think that will be very much inform his talk today. So Brad.
Yeah, thanks very much. I do want to talk to you about, in a way, a little bit different from most of the ambient intelligence stuff you'll hear about, because this is something that's going to happen from the bottom up, in my belief. The marriage of computers and cars, and in fact the computer is going to become the most important part of the car because it's going to be driving it. I use the word robocars, there are a lot of words for it. But this is a car that drives itself. Now, why do we want this? I have 5 major planks that I'll talk about. The first and most important being saving lives, but also energy and parking, the way we move in our cities, traffic, and finally delivery. So let's first talk about lives, because this on its own is more than enough reason to build a technology like this. Human drivers are pretty terrible in the amount that we drive, and we kill about, in the United States, about 33,000 people every year, and 1.2 million people are killed in car accidents around the world as well. Greatly greater numbers of people are injured. One of the largest causes of trauma injury, and the 7th largest cause of death in the United States. Now, the National Highway Transportation Safety Agency actually calculated the cost of accidents to American culture. That worked out to $230 billion when they did it, which, if you multiply everything together, worked out to about 8 cents a mile. Well, if you buy a more efficient car like the Toyota Prius, that's actually similar to the cost of gasoline. So you're paying as much for accidents when you drive as you're paying for gasoline in a vehicle like that. We also spend 50 billion hours every year doing this. Very, very important activity. If you think about that number, 50 billion hours, Americans only work 240 billion hours a year. It's a significant portion of the entire productive output of the United States. We have, I believe, what's the number? Oh, yes. The amount of time, the distance we drive every year, I worked this out, is half a light year. Now, how often do you get to use light years in your work if you're not an astronomer? That's in 3 trillion miles, an incredible amount of distance. Now, of all those fatalities, about 40% come from drinking, which robots never do, almost never. And 93% of the accidents are caused by humans, 80% of them because of inattention, another thing that robots don't do. Now, we lose 41 hours a year of our lives to congestion every year, and we've given up our cities to cars in a way that we've become blind to. There are 3 parking spaces for every car in the United States. Some people estimate even more than that. And 25% of our energy use and our CO2 pollution is going to cars. In the city of Los Angeles, it was estimated that possibly 60% of the land was roads or driveways or garages or parking lots. We've given over so much of our lives in cities to the car. What happens when a computer drives it? Well, this is not something from science fiction anymore. This is coming from Silicon Valley, where, let's face it, garage innovation has a tradition. But it's not the building of something as smart as a human, a full artificial intelligence. I consider this to be more artificial horse intelligence, maybe even artificial bug intelligence, and that's why we can do it. So several years ago, the US military set a series of contests to build these cars. And the first contest was a complete failure. Nobody got more than 7 miles from the gate. My friend Anthony tried to build a motorcycle and forgot to turn a part of it on when he began. The second contest, however, was a great success just 18 months later. And 5 cars completed a course of 150 miles through the desert, going down windy mountain ravines. There's no one in the car in the front, there's a chase car behind it, navigating a desert road. And Stanford was the team that won. Here they are coming up to the finish line. Well, Google decided to hire the people from Stanford as well as the people who won a later contest for urban driving to build the next generation of vehicle. And here we see that vehicle. This is Chris Urmson, chief engineer. engineer, just pushing the button, and here it is driving through the city of Palo Alto, mingling with other traffic and cars, stopping at stop signs, making turns, dealing with pedestrians. Google has said they thank these people for participating in their research. Now, what this car is doing is not seeing like a human, not driving like a human, but instead seeing in 360 degrees at all times. So it's been able to do things like drive through the streets of San Francisco, dealing with the traffic and the left turns and the lights, doing stuff like joggers running in front of it, not a problem, going through the toll booths on the Golden Gate Bridge, going through the California coast all the way down to Los Angeles, including here through the town of Monterey, driving on windy mountain roads in front of things that frankly would scare me as a human driver, seeing the same day or night and being able to deal with animals on the road. And for fun, it had to go down the windiest street in the world, as they call it, Lombard Street. This is sped up a little bit. I don't recommend Lombard Street at this particular speed. But also things that are hard, like merging onto highways. And then here also is a team from Stanford who taught their car how to park in a way I don't recommend. So it's not just these lab projects, though, in Google that are doing it. Many of the car companies are coming out with new vehicles with lane keeping, automatic cruise control. And in fact, in the next few years, you're going to see simple self-driving vehicles from most of the major car companies. This is Cadillac demonstrating what they call Super Cruise. This is a system where you can take your hands off the wheel, but you still have to watch like a cruise control. Volkswagen has a temporary autopilot they're doing. Audi has built a system both to do that and to valet park itself in parking lots. They demonstrated at CES this year. And Mercedes this year, the 2014 S-Class, will feature a product able to drive itself in a traffic jam in stop-and-go traffic. And Audi and VW and a number of other companies and Volvo have announced they'll have products in the next few years. I'm going to skip, because we're very short on time, a really nice video that Google made of their vehicle doing beyond highway driving, taking a person on errands throughout the day, and I'll point you to that later if you'd like to watch it, but it's 3 minutes, so we don't have time. So I decided when I saw all these numbers and all of these incredible effects that cars have on our world, that changing cars is one of the biggest things software was going to do this decade, and I wanted to work on it. The programmers can save the world. So how does it work technically? On top of the vehicle, the sensor that made the difference in the contest is a LiDAR. That's basically a laser radar that sends out pulses of light and times how long they take to come back, and can produce a 360-degree view of the world. You saw briefly this clip. You can see the circles on the road, which are painted by the laser. So the system receives this information, and it doesn't have to discern images from a camera. In fact, it doesn't really use a camera for much at all. Instead, it's able to identify all the obstacles on the road, or even if it doesn't identify them, know that they're there and perceive the way the world works. Now, there's also radar on the vehicle, which can see further and see through fog. There is a GPS, but in fact the GPS is not used any way that you don't use a GPS. Just roughly, where am I? It's not used to position you on the road. That would be crazy if you've ever seen where your GPS puts you when you're driving. So what do we see in a world of mobility on demand? This is a world where you pick up a mobile phone and you say, I need to go somewhere, and a vehicle arrives within a very short amount of time, a few minutes. And it's not like today's cars. It might even be a living room on wheels like this, or a single-person vehicle. What does that mean for how we move in society? Well, it actually has huge consequences for energy, because, as I said, 25% of our energy is spent on cars. It allows you to change the car buying decision from, what car do I need from my life, which is what we buy today, and so we always buy a big 5-passenger sedan or SUV or something like that, to what car do I need right now for this trip? And that means that people will use vehicles that they wouldn't buy today, because no one's going to buy one of these little dinky efficient cars for their life. They can't imagine they're going to give up skiing and give up everything else. But they'll happily ride on most of their trips, which are just alone and across town. That's the vast majority of trips that we take. We only take the big trips very rarely. So if you can have the right vehicle for the trip, you can suddenly change all the economics of transportation in cars and all the energy involved with them. In fact, this enables things like the electric car. Now, unless you have $100,000 to put down a Tesla, most people don't think an electric car has enough range for them, or has not enough, it takes too much time to charge the battery. They won't buy it. But you don't care about the range of your taxi. You just care if it's going to get you to where you are. And you can also use alternative fuels, which is great. Now, I used to predict that the thing that would slow this down the most would be the lawyers and the politicians. But in fact, bless their hearts, I rarely say that, but bless their hearts, they are working to actually enable the technology. And here is the first license plate for testing an autonomous vehicle issued by the state of Nevada, which passed a law enabling that, as has California and Florida and the District of Columbia, and 20 other states are working on it. We're also seeing people lobbying in front of it, people who are disabled, people who have children, people who want to get wasted and get home safely. And I always say that Jews are going to love this because there's nothing that Jews like more than arguing about whether it's legal to ride in a car like this on Saturday or not. Now, no technology is without its downsides. We could see this world where we need Fitbits to turn our refrigerators off because we're not walking anywhere. We could see people, instead of riding in small, efficient cars, deciding, hey, why don't I have an RV take me everywhere? In fact, why one RV? Why not have 6 RVs follow me everywhere I go and dock together and form a house? That's pretty cool. It's not particularly green. We might end up taking longer trips and getting more sprawl rather than less. And in more detail, if I had more time, I'd give you some issues about some of these other downsides. There are also some barriers to getting adoption of this technology. One of the biggest ones is that people don't like being killed by robots. And they'd rather be killed by drunks. Right? That's the downside to that. Obviously, nobody wants robots to kill people. But the truth is that this technology won't be perfect. And because it's not perfect, there will be accidents. And so the law might punish those accidents particularly hard because of this fear we have of it. But the reality is, if we don't deploy this technology, 34,000 people will be killed by other human drivers every year or more, a large number of them by drunks. And so when you think of the car as the second most dangerous consumer product that's legal to be sold, to be the most dangerous, you'd have to put it on fire and smoke it into your lungs. If you make that safer, I think that's a good thing, even if there are some consequences, much like medical technologies. There are also, of course, the regulators are still going to not be entirely blessed in their hearts. There's fear of terrorism, which this could be used for, and the small matter of actually programming the systems and making them work and be safe enough. But what gives me heart is that this is Moore's Law, our wonderful friend here in Silicon Valley, Moore's Law, coming to transportation for the first time, where there you might say the rule was that transportation gets twice as good every 100 years, if that. Now, the computer is going to be the most important part of the car, and it's going to be improving in that rate. In addition, the innovation is going to come from early adopters. Now, early adopters are basically stupid people with too much money, right? They'll go out and buy the 5 of something after they bought the 4S just a couple of months ago, and they'll spend a lot of money on it. And they drive companies to be able to innovate and produce cool new products because these early adopters will buy it. So we'll have that approach that gave us the internet and computer technology instead of the old transportation approach, which was municipal government administrators making big, long plans, which frankly, as nice as those people are, I know some of them, they're not early adopters. So we get to have a bottom-up approach instead of the big infrastructure approach, and I have a lot of heart from that. Very quickly, I'll tell you also these vehicles don't park. They would do what's called standing. And so I believe we're going to not need any of the parking that we currently have in a slightly more distant future, which means we can take all those parking lots and in a few cases at least turn them into parkland. We're also going to see massive changes to traffic and how we flow through cities. I believe we can get many, many more people down our roads than we get today with our existing vehicles. And I'll give you one final thing to think about. There is, for some reason in the United States, one product which is so important that we must be able to get it within 30 minutes no matter where we are. But imagine that you could get anything within 30 minutes. That a robot, not for carrying people now, but for carrying cargo that can do delivery, could bring you stuff within a very short time. That changes everything about retailing. It changes even how we own things. So these changes will go beyond the way our cities are structured and where we live and how we move, to also how we use and work with the products that we work with. You might ask a robot to bring you a guest room for the afternoon, and it might be practical to do that. So I have called for a reserve that maybe is a bit like the Apollo project long ago, and this nation should dedicate itself to achieving the goal before this decade is out of a computer driving a man to lunch at noon and returning him safely to work. And jokes about John F. Kennedy all aside, and I think that for those phrases, and also to do things not because they're easy but because they're hard, are some great inspirational phrases. I think there are very few projects in computing that offer such a big change to the world for what's comparatively little. The teams that are working on this are today quite small. So thanks very much, and I hope to have a car drive you home, not today, but some number of years in the future. And now I won't have cold beer when I go home, or warm beer, I mean.
Thank you, Brad. And I'm looking forward to seeing, the call for the end of no parking. I want to see where Jay picks up this this gauntlet that's been thrown.
Maybe we should have gone the other way.
Maybe we should have. So Jay is the program manager for SF Park at the San Francisco Municipal Transportation Agency, and it's a program that is very popular in my own house, and I imagine very popular among many San Franciscans. He's been in transportation innovation work for much of the past decade, and is also, I just found out this morning, is also a bike mechanic. So in your own time, so multimodal transportation. I'm looking forward to hearing from Jay. Thank you.
All right, thank you. And well, first of all, I'm Jay Primus. It's a real pleasure to be here to share what we've been working on in San Francisco to make parking smarter. And like Brad, I'm going to try to move really quickly so we can get back on schedule and have more time to chat. Before I start, I want to mention that I work for the San Francisco MTA. That's the agency in San Francisco that plans, manages, operates the city's transportation system. That includes everything you see here, including parking, both on-street parking, metered, unmetered, as well as 40 garages and lots owned by the city. And that parking is important because it's at the heart of so many quality of life issues and transportation issues that we face as a city. This picture is something, if you've ever been to San Francisco, you've seen before, and any other city where people like to come and get together. It's a picture of exactly what we're trying to avoid. If you look closely, you see that every parking space is taken, which means that people sometimes need to double park or end up circling around trying to find a space. This is obviously a senseless waste of time, which is precious for everybody. Fuel, greenhouse gas emissions. It's also dangerous. These are circling drivers, are distracted drivers looking around for a parking space, making lots of right and left turns. So they're much more likely to hit a pedestrian, cyclist, or another car. We want to see a lot less of this. And stuck in the middle is transit. Waiting, slowly negotiating double parked cars or cars waiting to make right or left turns. This is part of the reason why transit isn't as fast or reliable as it could be. So how did we get here? Clearly something isn't working. For decades, San Francisco, like every other city in the US, has managed parking in the same way, with meters, but with a real emphasis on short time limits. And you see here, this is a picture of the mayor in 1947 operating the city's first parking meter with a 60-minute time limit, which is not very convenient, but the approach makes sense given the available technology, that I pull in, do my business, I have to leave so that you can come and do the same thing. But clearly, it's not delivering the outcomes we want to see most of the time. So instead, what are we doing about this? We're really trying to use data to manage parking demand towards a singular goal of availability, or in other words, trying to make it so that your experience as a driver is that most of the time there's an open parking space on every block. And that would be great. Saves you time and would dramatically reduce double parking and circling. And also, to the extent that it delivers those benefits, we expect to get a lot of broader social benefits, whether for the environment, safety, economic vitality, or just enhanced mobility, helping people get around whether or not they're in a car or on transit. I think part of what's new here also that's really worth underscoring is that finally we're recognizing parking as a powerful tool to achieve our goals as a city, rather than just a way to balance our budgets, which is what it's been in the past. So with that focus on availability and making parking easier, San Francisco received federal funding to do a demonstration, first in the world, of this approach to managing parking. It's been in place since 2011 in these neighborhoods that represent about 7,000 of the city's 28,000 metered spaces, as well as 14 of our municipally owned parking garages. Part of the package is simply, finally, making it easy to pay at the meter. Rather than carrying around bags of quarters, meters that accept credit cards and phones in addition to coins and smart cards. At the meter, we've also lengthened time limits, really de-emphasizing time limits as the way to achieve availability. So relaxing them to 4 hours, and in some places, no time limit at all. Really using price to manage demand. But at the heart of the project is what you see here, a parking sensor, the size of a hockey puck, embedded in every metered space, ultra low power mesh network, crazy, incredible technology with one battery set, sensing and continuously and communicating real-time data continuously 24/7 for 2 years and counting. And the really cool thing about that data, of course, is that it's real-time data. So it comes to us, and we share that as a data feed, but it's something that we can share with customers to try to get them matched up with a parking space and off the road as quickly as possible. So we've made an app, of course, you can download it for free, but more importantly, that data feed has enabled other people to make apps and help us get that information out there to achieve the social benefit we're looking for. These are just a few of the examples of what people have done with it. But not everyone has smartphones, and of course, no one should be using that phone while driving. This is a really primitive start of what real-time information is going to look like. I think just in a few years it will look different. So we've also focused, very importantly, on really low-tech ways of getting information out there. Even people who lived in San Francisco for many years don't always know how to get right to that garage or lot. So if you've been to San Francisco in the last couple of years, I hope you've noticed the hundreds of new wayfinding signs that just try to direct people to those garages and lots where we almost always have space, so they get off the road fast. But the project's, the heart of the project, if there's secret sauce, this is it. It's demand responsive pricing. And what this means is that every 6 weeks, we gradually adjust rates up or down by 25 cents an hour. And we can adjust rates by block, by time of day, like you see here, or by day of week, weekdays versus weekends, which have different demand profiles. And with this price, we're legally obligated to find the lowest price possible at the meter that delivers that one space open most of the time. And now, of those 7,000 spaces, about 11%, the rate is now 25 cents an hour, which is probably the cheapest parking in California. So we've lowered rates more than we've raised them as we constantly seek the lowest price possible. At garages, we're using the exact same approach, but you can also get an off-peak discount, which means that if you enter a garage or exit before or after a certain time, you can get a $2 discount on either end, which means a total discount of up to $4. And that's a really powerful incentive to try to get people to drive when the roads aren't quite so busy, earlier in the morning or later in the day. So this is very similar to congestion pricing schemes that you might have heard about in London or Stockholm, but framed correctly as a discount rather than a peak period surcharge. Everyone loves a discount. Everyone hates paying a peak period surcharge. And this is, of all the things we've done on this project, this gets the least amount of attention, but maybe the simplest, most innovative thing we're doing. It's congestion pricing with none of the technology, and it can be done at a stroke of a pen. To determine rate changes, we process all that sensor data from the garages, to find out whether or not to raise or lower rates. And the rules and data we use to make those determinations are all posted online at sfpark.org. So this is a completely data-driven, rules-based, and data-driven process. And transparent was the other word there. Another part of the project is enforcement. Trying to make it easy for people to avoid tickets. And by making it easy to pay and having longer time limits, we've really done that. We've seen tickets drop dramatically. And this is great customer service for us. It's also great for our parking control officers. They frees them up to do other things like focus on double parking or other quality of life issues. The bad news with enforcement is that, yes, we're bringing together real-time data from meters and sensors to show those officers what spaces are occupied but unpaid. So helping them do their jobs more efficiently, which is what we want government workers to do. So that we're testing that out, 10 Galaxy tablets mounted in 10 vehicles. Testing that out and really seeing does that work.
I was with you up to that.
It sounded good. Yeah, we usually don't highlight that part of the projects, but it is interesting. And also, as a demonstration project, we've taken very seriously the responsibility for evaluating it. This is really the first city in the world that's done this approach. So absurdly, one first step was just understanding how much parking we have. Using the maxim that you can't manage what you can't measure, we didn't know the answer to the question, how many publicly available parking spaces are there? So we set out one by one to count every space on and off street in the city. This was a critical foundation for the project, and we believe that we're the first city in the world to have done it. We're also gathering all the data that we and an independent evaluation team, federal evaluation team, need to evaluate all the hypotheses of this project. Does it really deliver improved economic vitality? Does it help transit work better, reduce greenhouse gas emissions, and so on? So this is all the data that's coming in. And obviously, well, maybe not as obviously, data from the sensors, meters, this is an avalanche of data. It's terabytes. And we knew from the start that Excel wasn't going to cut it. So we, unusually for a municipal agency, made a real investment in data management and analytical tools that you would normally find in the private sector, but bringing them to bear in a municipal agency to deliver social benefits. This is those tools, but really with that, there's an ulterior motive. It's not just to manage parking or evaluate this project, but it's to help us as an agency hopefully make a quantum leap and start using data to make smarter decisions about how we operate the whole transportation system, as well as just improve our administration. This investment in data management is a pretty big deal. You know, we had a lot of data lying around, but we didn't know what to do with it. We couldn't get a lot of value out of it. So by structuring that data, we're really able to start getting at it in ways that will enable not just operating this pilot project or evaluating it, but we're starting to weave that into the day-to-day operations of our agency, performance measurement, contract management. So that's a quick overview of what we've been doing in San Francisco. We'll be evaluating the project later this year. We just finished some of our after data collection. And what's interesting about the project is that to the extent that this delivers the benefits we expect, it's very easy to replicate in other cities. Every city has parking stuff, so this could be something you see more of in more cities soon. If you'd like to learn more, at sfpark.org, we've tried to have that website be very information rich, including in the resources section, a 130-page PDF that shares a pretty in-depth summary of what we've done with the project and lesson learned thus far. Well, thank you, and this is my email address in case we don't have time to get to every question today, or in case you'd like to be in touch.
Thank you. So we do want to throw it open to the audience for questions. I had one that at least I want to get out. I hypothesized that this might be the war story panel of the day. And in a way, you're all at different stages of rolling out systems of ambient intelligence. I mean, Mark, you convince people to swallow sensors every day. You know, the self-driving car has changed politicians. It's logged hundreds of thousands of miles. And I mean, Jay, you got a city that is very contentious for transportation, to enact this really big change. So I'm wondering about the role of, I was thinking of it as both as kind of communication and community outreach, community discussion as we move towards world of ambient intelligence. Do you have any, I mean, going back to this idea of war stories or any lessons on what is the role of communicating the benefits or communicating how the potentials are communicated for the benefits to actually take hold? And I think this is I'd say for anyone or everyone on the panel.
Sure, I'll go first. So in our case, I think there's a psychological difference. It's like a tipping point where the thought of putting a silicon chip in a medicine, people think of all the negatives, until you actually talk to a person who actually has a chronic disease. And then the whole dynamic changes. It's like I've got this portable nurse that's following me around. Instead of being in a hospital, I've got that level of care personally and with me all the time that's looking at more than just medicine. It's looking at heart rate, and just like as if you were in a clinic. And so what's sometimes difficult is when you're in an audience of healthy people like this, they don't necessarily perceive the benefits of a technology. They just see the risks. And I imagine that's going to be true for the cars, where people, you laid out the cars extremely well. But a lot of people just think of the risks of that. And by the way, before I lose the microphone again, I've been an inventor for 30 years and then share a lot of stages. And I just want to say this is the first time where I've shared a stage with someone from the government who I don't normally associate with innovation, talking about something truly innovative. So I wanted to give you a thumbs up.
So I love it when innovation comes from the bottom up without, that it surprises people. The best innovations in the world have always been a big surprise. I mean, the people working in it have known about it, but suddenly people are buying things, and as I said, those early adopters, and they aren't really stupid. They really actually are driving new technologies. And the one thing that we want to talk about policy on, which was talked about at the previous panel, are the privacy issues. One of my other hats is I was chairman 10 years of the Electronic Frontier Foundation. We're a privacy rights foundation. I can hold contradictory ideas in my head, no problem. But there are some serious consequences with ambient intelligence on that respect. I think the SF Park system has been designed in a very rare bout of this to actually not try and collect more identity data than they need to. So many of these systems, there's just a natural instinct, both by the programmers and the business people, to say, why would I throw away data? Why wouldn't I want to get everything I can? And that builds these huge repositories that become privacy, attractive nuisances, and I'm thrilled that you're not doing that.
For us, there was a real emphasis on communications, just basic brand management and product design 101 that is uncommon in government agencies. We were really asking people to have a different relationship with parking, and that was part of the reason to create a brand, SF Park. But I don't think accepting sensors was that difficult. In some ways, people expect that. They love having real-time data to help them find a parking space. Once we dispelled some of the myths and were very open and transparent about what we're using them for. The bigger challenge was just, with sensors in particular, were all the practical operational headaches. The sensors are embedded in the pavement, so you can imagine what a headache that was in terms of installation, and just day to day as the streets get torn up by PG&E, keeping track of that is a nightmare. So the sensorization sounds great, at least for parking sensors. That's been the practical challenges have been considerable.
For transparency, by the way, I'll give you your map of where the people who have got expired meters are, if you'll give me a map of where the enforcement people are.
Actually, I had a question for you though too. Is why worry about the tickets? Once you swipe your card, you should just
let me increase the meter.
Let them go until they leave.
Would love to see it. Meter technology is not. It's still rooted in the 80s. We're trying to working with them to. We have something in the works to make that possible. So you pay only for the time that you're there.
Great.
Go out to the room.
Do we have any questions from the audience? We have mic runners. If you would just say your name and where you're from.
So I'm Talis Blaylock, and I have 2 questions related to cost. I'm curious, how much does it cost per pill, for the health-related issues? Because obviously that impacts kind of what type of diseases you can track. And I'm also curious from the San Francisco point of view, how much did it cost you to implement all of this when you're talking about the cost of the sensors, all the work, and especially, keeping track of it and building the system, et cetera?
So today we get about 20,000 1mm die per 8-inch wafer. And wafers are ballpark less than $1,000 or so. So that's the raw cost. And when you get to higher and higher volumes, we ship 2 million pills or chips in the first quarter, about 10 million by the rest of the year. We expect about 100 million next year in ballpark numbers. So as you go up that volume curve, as with all semiconductors, the costs go down. And we have a roadmap of strategies to reduce the cost of the system so that what you start thinking about is not the cost, because the cost of manufacturing of a medical device, you think of it compared to the sales price, or you think of it in terms of the value that you're providing. The pills don't do any benefit if they're not being eaten properly, and you can tie it to that value proposition of instead. So the cost is, right now, it's early adopter years. They're still not where we want them to be in time, but over time they'll be relatively insignificant, and will be. In fact, there's even business models where you give the pills away. They're only reimbursed when you actually eat them, or the data for really low-cost pills, such as for diabetes, for example, metformin, which is very common and pennies per pill. The data is more valuable than the pill itself. So there's a lot of ways of looking at it besides just the cost of the chip.
And for SF Park, it depends what you include under that umbrella, but it was funded by about a $25 million grant from USDOT.
Behind you.
Yeah, near me, right there.
Troublemaker.
Hi, Dave Marvett, Fujitsu Labs. I'm just curious about how elastic the pricing is on parking. I mean, like, I have to park. If it's 50 cents or 25 cents or $2, I'm kind of stuck. So I just wonder, as you try and twiddle these prices, how much of an impact that actually has.
Well, I can't tell you right now. It's not a secret, but we're gearing up for the evaluation. It's one of the biggest questions that this is a boon for transportation research. Never before has this data set been available, so it's unprecedented. But that's one of the most basic questions that we're looking at for on-street and off. How do people respond to prices? It's looking like about 0.3 So, for every 10% change in rates, as a rough rule of thumb, but there's a lot of variation, but for every 10% change in rates up or down, that demand goes up or down by 3%, roughly.
That's a number.
Back there, please.
Hi, I'm Rick Rogers with UCSF. I have a question for Jay and a question for Brad. Jay, although I'm curious to know actually how many residents download a 103-page manual about parking, what I'd really like to ask you is what sort of failure modes and failure rates do you observe with your parking sensors? And then for Brad, you stated that robots don't drink, but I take it you've never seen Futurama?
Well, as far as failure rates for the sensors, I'm not sure off the top of my head. There's about 8,000 spaces that have sensors in them, and there's a crew working by the sensor vendor working constantly, trying to keep those up. So on the order of several hundred a month are failing, and at this point we're starting to see battery failures.
So bite my shiny metal ass. No, seriously though, while the robots don't drink, the software will obviously have different failure modes from human beings. That's one of the most common failure modes for people is, of course, they get impaired and they go out. The failure modes for software will be different. Everyone is working basically to get a vehicle which can drive more safely than a human being and to prove that they've done that. And when they have done that, I think they'll be ready to release. But there will still be failure modes, and I have some articles on my robocars.com website that discuss some of those for you. So.
Do we have time? What last question? I think right there.
Mark Cummings, Orchestral Networks. I want to follow up on Brad's earlier comment about privacy. I'd like to introduce a new technical term, and I'd like to embed it in everybody's head if I can. It's forgettery.
It's what?
Just because we capture data doesn't mean we have to keep it. Our whole technology and our whole policy has been, more data is better. If we get something, we should keep it, and the longer we keep it, the better.
But as I've said, the instinct of so many software developers and so many business people is to think, why would I throw away something that could be useful to me in the future? And even though you haven't figured out why it's useful, you always have an instinct that it could be useful. But you're absolutely right, and there are, in a number of legal jurisdictions, data retention limits. The data must be erased or anonymized to a certain degree after that time. Unfortunately, there are also jurisdictions going the other way, which are doing data retention minimums. And that's because law enforcement wants to be able to track people and go and look at records 6 months after. So two forces are fighting each other there, and I wish you could get your wish. I don't know if you will.
But the data is very important, particularly in our domain, and certainly our patients will own their data, so there's no question that they can do with it what they like. We expect many of them to, at some point, allow their disembodied data, so take away all the personal information, and you have something just like the genomics, just like their response to the therapy, going into a database. And then you can start doing virtual clinical trials, where today, if you have a patient who's diabetic and schizophrenic, they would not be in either of those clinical trials for a medicine. So they're removed from the diabetes if they're in schizophrenic, and they're removed from schizophrenic if they're diabetic, those trials. But now, if you're gathering data when they're taking medicines for both, you're learning information about those types of combinations. And combination of multiple morbidity, multiple issues is going to increase as our populations get older and our therapies improve. I mean, the reason why we have this problem in the first place is now we have a way to treat people for many, many diseases that didn't exist 30 years. And people are living much, much longer as a result. So we have a good problem to have, if you think about it in that perspective. And these are the types of tools that over long periods of time will allow us to be more selective in choosing the appropriate medicines for the right patients.
Join me in thanking the panel.